Okay, so now let's try to use the PhStat to determine the sample sizes. And even if you don't have PhStat, you basically could use those formulas. And I'll show you, spend a little bit of time on those formulas. So let me go to share my screen. Okay, and so we have the the regular PhStat add-in right here, and we could go to sampling, confidence intervals, sorry, and below that we have sample size. So let's just look at the computation of the sample size requirement for the mean. Now, and in our example, in our slides, we had the population standard deviation as 45. Error margin was requested to be plus and minus 5. Confidence was requested to be 90. At this point, let's not worry about the finite population correction, and let's do it. Okay. And so this is the example that we did on the slide, and the result is the same. Here it's rounding up using the roundup function of the result. And the result is basically the same formula. It uses the z-value, which is B9, and the z-value uses the norms.in function. And as input to that, it uses 1 minus the confidence level, given as 90% here. Okay. Now, this number is really 0.90. So it's just from formats, we selected it to be a percentage. If I just make it into a number, all right, and also just something maybe we can need in the future if you increase the decimal points, because it was set to be already 0 decimal. So this is 0.90. So now you can construct these sheets yourself, and you have to use, of course, the confidence level as 0.90, not 90. Supplied confidence error and population standard deviation and the required sample size. So if we, for example, decrease the confidence level, the sample size required will also decrease. Okay. So this is for the confidence interval for the mean, sample size determination for the mean. What if we want to determine the sample size for the proportion? And now we have estimate of the true proportion. And let me use the same number in the slides. And you see here, I'm also using the dot as the decimal. So because the PhStat program recognizes the dot. Sampling error, we want to be plus and minus 7%, and that should be entered as 0.07. Okay. Again, don't worry about this correction. So what we need, what we have here is again the roundup function and the formula itself that determines the sample size for the proportion. We've got here again the z-value 196 squared times the proportion we entered in before, 1 minus the proportion we entered. Okay, and then divided by the error we specified squared. So for example, what if we requested 1% error? And you see now the sample size requirement grows so large, 4,898. Again, we saw something like this. What if we want to use the worst case? Let us estimate the true proportion as 0.50. So what will happen now? Now you see the 5,000 requirement actually increased to 9,600. So let's go over again our input estimate of the proportion. Error we desire, and should be in 0.01, not 1 or 2. Confidence level, which the format is selected as percentage. So you just, when you enter values here, you should use 0 point. So if I enter here 0.80, okay, and sorry. Okay, you can enter values as 80, that's fine. Okay, but the value inside there is 0.8. So then there is the z-value corresponding to 80% confidence, and this time the calculated sample size required is almost half. So 90% to 80% we are reducing the sample size requirement. Okay, so